Okay, now we're going to look at the centre of gravity calculating software, which can be used with the compression load cells, so wireless compression load cells. So let's start again in the load cell database. We've scanned for our load cells, and you'll see they're populated here. Then we go into project setup. Let's create a new project, and we'll put this as centre of gravity calcs, and with compression cells. Now we need to add our load cells, and we're going to add 4 load cells in this case. So load cell 1, now what's different with the compression load cells for calculated centre of gravity is we need to tell the software exactly where each load cell is located. So we go into show advanced settings, we toggle centre of gravity on, and then load cell 1 we're going to say is as we view the object from a bird's eye view, so from above, we're going to tell the software where the first load cell is located on the x-axis and on the y-axis. So let's say load cell 1 is in the bottom left hand corner, in which case it's 0 on the x-axis, 0 on the y-axis. And what units, so units of distance, are we measuring in? So we're going to measure in millimeters, because let's say that this object is 7 meters by 3 meters. So there we add our first load cell. Next, let's add our second load cell. Again, show advanced settings, centre of gravity, toggle that on, and this one is going to be 7 meters across, so 7,000 millimeters across on the x-axis. Then let's add load cell 3. Again, show advanced settings and toggle centre of gravity on, and we want 7,000 on the x-axis and 3,000 on the y-axis. So this is in the top right hand corner. And then fourth load cell, show advanced settings, centre of gravity, and then this would be 0 on the x-axis and 3,000 on the y-axis. So this is in the top left hand corner. Now let's click on load cell displays. Just see that we're getting a signal from all 4 of these load cells. And we want to click on the centre of gravity view over here. So we've got a signal from all of these. Let's click on centre of gravity. And now you'll see we've got a live view of the centre of gravity showing exactly the coordinates of each load cell. So load cell 1 is at 0, 0. And this is load cell DDD1 with 14.9 tons on it. Load cell 2 located at 7,000 millimeters and 0 millimeters up, and 11.45 tons on it. Load cell 3, the top right corner, at position 7,000 millimeters and 3,000 millimeters with 13.73 tons on it. And load cell 4 located at 0 on the x-axis, 3,000 on the y-axis with 3.97 tons on. And we could add some load onto load cell number 4, and you'll see that load cell 4, the dot gets bigger to show the extra load that's on there, and you'll see that the live centre of gravity position is moving across towards it as you add more load on there. Now we can then create a report from this information, so we click on enter the job details. So let's just say we want to create some fictional details on there. So fill those in and then click Save. Now there's an ISO standard, ISO 19901, which says that to calculate centre of gravity you need to take 3 weighings. So we've got here the centre of gravity records. This defaults to 3, but you can actually do anything up to 10 if you would like. But essentially we do 3 weighings and then get the average of those 3 weighings just to make sure that there's an accurate weight to even out any discrepancies. So once we're happy with that everything's set up correctly, we can record our first weighing, record our second weighing, record our third weighing, and you'll see then that up here, Generate Report is now highlighted. If we click on this, it will generate us an HTML report, which is our centre of gravity report, showing us exactly where the average centre of gravity position is in millimeters, because those are the units we chose. But we could choose for a much larger object that to be in centimeters or to be in meters. But for objects that are several meters long by several meters wide, you will get the most accurate results by putting those in millimeters. But you'll see the average from the 3 weighings is 2993 on the x-axis and 1656 on the y-axis, and the mean weight from our 3 weighings